Hi, welcome to the video of binary operation. In this video, we will discuss about binary operation defined on set and its algebraic structure. At the end of this video, you will be able to define binary operations and define algebraic structures. So let's move to the definition of binary operation. Before defining binary operation, let us try to understand this concept with the help of simple example. Suppose you are having a set which consists of two types of water. One is the plain water and one is a sweet water. So these are the two elements of the set. What we are going to do is we are going to mix the plain water with the sweet water. When we are going to mix plain water with the sweet water, the result comes out to be a sweet water, but little bit less sweeter as compared to what we are having in our set. But the property is same, that it is a sweet water. So what we are saying, we will consider it that this sweet water is also an element of the set. So the process we are doing is, the operation what we are doing is mixing of these two water, and we are saying that the result is again the element from the set what we already have, means that it is a sweet water. So this is what a binary operation means. It says that if you are taking any two elements from the set, apply the operation, the result should also be in the same set. So let's look at the proper definition of a binary operation. It says that binary operation on a set S is a mapping star that assigns to each order pair of elements of the set S a unique determined element of S. Means that the result should also be an element of the set S and it should be unique. Looking at the mapping from as discussed, the star is a mapping from S cross S to S. Then the set is closed with respect to binary operation, means to say that star acting on the two elements A, B, it is denoted as A star B, and this A star B should also be an element of S and it should be unique. If this thing satisfies, then we say that star, the mapping, is a binary operation on the set S. So hence we are saying that star is a binary operation on the set S. The different symbols used for denoting the binary operation are plus, multiplication, O, star, and you can use slash also, slash, hyphen, anything. But the main motto is that you are taking two elements, put the symbol there, the result should also be an element from the same set which you are considering. Important point to be remembered is that suppose you have a set which consists of n elements. Then can you tell us, without having all those calculations, that if a set has n elements, then how many possible binary operations can be there? So with this result you can easily find out that how many possible binary operations can be there on a set having n element. It says that if a set has n elements, then the number of possible binary operations on that set is n to the power n square. Let us discuss the smaller case. Suppose a set A has two elements, then what would be the total number of binary operations? Just use the above formula. It says that n to the power n square. What is the n here in this case? N is 2. So 2 to the power 2 square. 2 square is 4, means 2 to the power 4. This comes out to be 16. So it says that if a set has two elements, then the number of possible binary operations on that set can be 16. Let's look at some of the binary operations. Let us suppose that Z is a set of integers and we are taking the operation as an addition on the set Z. Then we will show that this set Z with the addition as a as an operation addition, this set is a binary operation. So how we are going to show that addition is a binary operation on the set of integers? What we will do, take any two elements from the set Z, add them, the result should be in the same set Z. This is what it is written there. Suppose m and n are two integers from the set of integers, and then apply the binary operation addition. So it comes out to be m plus n. Because we know that addition of integer is again going to be an integer, so we can say that m plus n is also an integer. Let us move to some particular example. Let us take minus 5 and 3. So minus 5 is an integer, 3 is an integer. If we are going to add these two integers, the result is minus 2, and minus 2 is again an integer. So this shows that addition is a binary operation on the set of integers. Similarly, we can show that multiplication is a binary operation on the set of rationals. Why? How to show that multiplication is a binary operation on the set of rationals? If we can prove that multiply any two rational number and the result is going to be a rational number, then we are done. And we know that if we are multiplying any two rational number, the result is always going to be a rational number. Hence, multiplication is a binary operation on the set of rationals. Let us consider some more examples. We are having two sets E consisting of even integers 0 plus minus 2 plus minus 4 plus minus 6 and so on, and odd integers plus minus 1 plus minus 3 plus minus 5 and so on. So, if we are going to define a usual addition on E, means that the set of even integers, we can say that it is a binary operation. Why? Because addition of two even integers is again an even integer. But if we are going to apply the addition as a binary operation on the set of O, means that odd integers, then it is not a binary operation. As you can easily see that, take the two elements from the set O. Let it be 1 and 3. You are going to add it. 1 plus 3, it is 4. 4 is not an element of the set O. So, addition is not a binary operation on the set O. Consider the set of real numbers and define R cross R is the order pair AB, where first element A belongs to the first set R, the second order pair element B, it belongs to the second set R. Then we define the addition as AB, order pair AB is defined as the result is A plus B. Now we will show that whether this is a binary operation or not. So let us study it with some particular cases. Let A is equals to 5 and B is equals to 3. So the order pair 5C as defined above, it comes out to be 5 plus 3. So 5 plus 3 is the number 8, and number 8 is a real number. So this means that the binary operation addition for the set of real numbers, it satisfies the case, so it is a binary operation. Now, let's define multiplication on the set of real numbers. It is defined as A dot B. So, let's find out whether this is a binary operation or not. So, we are taking here A is equals to 2 and B is equals to minus 5. If we are going to multiply 2 and minus 5, the result is minus 10. And you know that minus 10 is a real number. So, it is shown that multiplication is also a binary operation on the set of real numbers. If you are taking the case of natural numbers and you are defining the binary operation as A star B is equals to AB, means that multiplication of two natural numbers, then we can easily show that this multiplication is going to be a binary operation on the set of natural numbers. Considering these two particular cases of A and B, A is equals to 2 and B is equals to 3, you are multiplying 2 and 3, the result is 6, so which is again a natural number. So, we can say that multiplication is a binary operation on the set of natural numbers. Let's look at some other example. Consider the set of real numbers. In the operation, we are defining it as A star B is equals to 3A plus B. And we will show that this sort of operation defining on the set of real numbers is actually a binary operation. Consider the special cases of A and B. A to be equals to 1, B to be equals to 6. So, 3 into 1 plus 6 is 9, which is again a real number. So, it is a binary operation. I am taking the particular cases of A is equals to 1 and B is equals to 6. You can take any number whatever you want for A and B and just substitute it in the equation. You will find out whatever the number you are choosing, the result is always going to be a real number. So, in this way we have proved that this operation is actually a binary operation on the set of real numbers. Let us now consider the cases when the operation is not a binary operation. Let us consider the set of integers Z. Then we know that addition and multiplication are binary operations on the set of integers. But what about division? Is the division operation also going to be a binary operation in the set of integers? No. Consider the specific case. 1 is an integer, 2 is an integer. But what about 1 by 2? 1 by 2 is not an integer, it is a rational number. So hence, addition and multiplication are binary operations on the set of integers, but division is not a binary operation on the set of integers. Now let's define what you mean by algebraic structure. What do you mean by algebraic structure? It is a non-empty set with one or more binary operations. For example, consider the set of integers. Just now we have shown that the set of integers with addition or multiplication, it is a binary operation on the set of integers. So we can say that the set Z with addition is a algebraic structure, or set of Z with multiplication as a binary operation is a algebraic structure, or we can say that set Z with both addition and multiplication as a binary operation is an algebraic structure. So look at here. So how we are going to denote this algebraic structure? It says that if G is any set and plus, minus, star, O, anything is a binary operation, then G, comma, plus is a algebraic structure for that set. In this video, you learned that if a set has n elements, then there are n to the power n square possible binary operations on that set. So similar case, if A has 2 elements, then it has possible 16 binary operations on that set. And a non-empty set with one or more binary operations is called algebraic structure. Binary operations are used in computer programming, algorithm designing, and many more ways.